morning, students. Today, we are going to see the next important session, or we can say the next important concept of electrical system of automobile, that is the relays. These relays are very much used in automobiles. They are having their own advantages. So why they are used as a switch in our automobiles, that we are going to see in the today's session. So let's start the session. Now, first of all, this relay is a magnetic type of a switch which uses a movable armature to control the heavy electrical load by using a low amperage electrical switch. This most automotive relays added to common terminal identification, that are the relay use the terminals for the power side, for the ground side. Okay, so for every manufacturer uses the same terminology for manufacturing the terminals of a relay. Relays are found in many circuits because they are capable of being controlled by the computers, yet are able to handle enough current to power the motors and accessories. Now, we will see this one is the typical connections of relay. The terminal 86 and 85 are nothing but a coil which gets magnetized. Okay, now this 30 indicates that this one is the power side. Now this power side is connected to 87A for a normally closed type of output, and for the 87 for normally open type of output. Now the resistance of most of the relays is in between 50 to 100 ohms. Okay, now here this 86 now is connected to the power side of the coil, and this 85 to the ground side of the coil. Now this is the internal structure of a relay. The main important part of the relay is this coil. This coil is having the terminal 86 and another terminal 85. This 85 is connected to the ground, whereas the 86 is connected to the power side. Whenever from the power side is current passes through the 86, then this coil gets magnetized, and due to which this movable armature, it is attracted due to the magnetic effect on this coil. So due to which this contact closes. As this contact closes, the current from this power side moves directly to this 87, this other side, and due to which by using a very small amount of current, we can manage a high electrical loads which requires huge currents for their operations. Now, most of the relays are having 4 terminals, or in case certain terminals are having 5 terminals. These diagrams, we can see this is one type of a relay, okay, and this is the relay socket, okay. Now, the coil which provides the magnetic pull to the movable armature, okay, is the most important component of this relay. The resistance of the relay coil is in between 50 to 150 ohms, but it is usually between 60 and 100 ohms. The International Standard Organization ISO identification of the coil terminals are 86 and 85. The terminal 86 represents the power side of the relay, while the 85 represents the ground side of the relay. The relay coil can be controlled by supplying either power or ground to the relay coil windings. Now, the high amperage current flow through the relay from the terminal 37 and 87, or often 87A for normally closed type of a relay. The terminal 830 is usually the power applied when the relay is at the rest without any power, and ground to the coil. The armature inside the relay electrically connects the terminal 30 and 87A if the relay has 5 terminals. When there is a power at the terminal 86 and a ground at the terminal 85 of the relay, the magnetic field is created in the coil winding, which draws the armature of the relay towards the coil. The armature, when energized electrically, connects terminal 30 and 87. The maximum current that can be drawn to the relay is determined by the resistance of the circuit, and the relay are designed to safely handle the design current flow. Now here we can see the two configurations of the relay. One is the normally open and one is the normally closed type of a relay. Now this is a typical applications of a relay which is used in the horn circuit of an automobile. You can see here, this one is the horn switch. One end is grounded, other end is connected to point 1. We call it as the point number, or grounded, or we can say it is nothing but terminal 85 or 86. Okay. Now here what happens, we can consider this as the ground side of a relay, and point number 2 as the terminal 86 of the relay. Now here, due to this point number 3, it can also indicate the terminal 87 of the relay. Point number 2 from here, it indicates the power side of the relay. Okay, whenever current flows to point number 2 to 1, so what is going to happen? This coil will get energized, and due to this magnetic effect, this circuit will close, and this will allow the current to flow from point 2 to point 3 and point 5. And from this, it will go to left hand horn and right hand horn, and due to which we can get the experience of the horn. Okay. Now this is the particular applications of a relay in the horn circuit of an automobile. Now there are certain, we can say, devices which are used for the smooth operation of the relay. So what happens whenever relay, as we all know, the relay consists of a coil, and whenever the power is removed, the magnetic field surrounding the coil collapses, which creates a voltage that is induced in the coil winding. This voltage induced can be as high as 100 volts and can cause problems with the other electronic devices in the vehicles. The short high voltage surge can be heard as a pop in the radio. To reduce this induced voltage, some relays consist of a diode which is connected across the coil in the reverse bias directions. Okay. Now, when a relay or a solenoid coil current is turned off, stored energy of the coil forward biases the clamping diode and effectively reduces these voltage spikes. There is another important, or we can say another method which is used to reduce these voltage spikes. That is nothing but installing a resistance across this coil. Now this resistor value is typically from 400 to 600 ohms. This reduces the voltage spikes by providing the path for the voltage which is created in the coil to flow back to the coil winding whenever the coil circuit is on. Okay, so the resistors which is used in parallel with the coil windings is commonly used for the spike reduction methods, and which is used in many relays. Okay, so I hope you have understood the operation of this relay. If any doubt, please feel free to contact me or to drop me an email. So today we will stop over here. We will see in the next lecture.